everyone. I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to discuss maximization case of assignment problem and basic concepts of game theory and how to find out saddle point and how to solve 2 by 2 games with saddle point and without saddle point. Here is a problem which is in maximization model. So, you may have doubt how to identify whether the given assignment problem is in maximization model or in minimization model. So, if the problem talks about costs, okay, and time, so always the organization's goal is to minimum completion of the task in minimum time and completing the task with least cost. Okay, so if such kind of concepts if you find in the problem, then we must understand that the assignment problem is in minimization model. If the problem talks about profits or gains or sales, so always the organization objective is to maximize the sales or maximize the profit. Therefore, if the given assignment problem involves the concepts like profits or talks about sales and all, then you must understand that the problem is in maximization model. So, remember, whenever you are solving assignment problem, the problem must be in minimization model only. So, here we have considered a problem which is in maximization model. So, we have to convert this given maximization problem into minimization model. How to convert? So, in the given assignment problem, all these are the profits earned by the organization, right? So, identify the maximum value, highest value in the given problem. Okay, so 42 is the highest value. Therefore, subtract all the other elements from this maximum value. So, this is how you can convert the given assignment problem which is in maximization model into minimization model. There 42 minus 42 is 0. 42 minus 35 is 7. So, like this, all the other elements must be subtracted from this maximum value. After converting the problem into minimization model in this way, now the procedure is same which we have discussed in the previous lecture, that is perform row minimum and identify minimum element in the row and subtract all other elements from that, and do the same for in case of columns also, and then make assignments and then identify whether the assignment is optimum or not, and then draw the minimum lines, and the procedure goes on, which we have discussed in the previous lecture. So, this is how we can solve when the assignment problem is in maximization model. Okay, and let us move on to the key concepts of game theory. So, first we should understand what is the exact meaning for the term game. So, game means it is a competitive situation which leads to gains for one player, losses to the another player. So, game is a competitive situation which involves 2 or more players. When there are 2 or more players, if one player is going to make profit, it means that the other player is going to make loss. Okay, such kind of competitive situation we call it as game. And we have, when we talk about game theory or games, we come across with the term strategies. So, what is the exact meaning for the term strategy? Strategy is nothing but the plan of action which the player is going to use in against to his competitor. Okay, so such plan of action of a player is called strategy. And next, payoff. Payoff is the amount or the quantity of an outcome which results when a player uses a particular plan of action against to his competitor. So, the value of the outcome or result is against to a strategy used by the player is called payoff. Okay. And then we have various types of games. We call 2-person game, 3-person game, n-person game. So, what is this 2-person game? So, if the game involves 2 players, it is called 2-person game. When the game involves 3 players, it is called 3-person game. If the game involves n players, it is called n-person game. Okay. And we also talk, sometimes we use 2-person zero-sum game. There are 2 types of games, zero-sum game, non-zero-sum game. So, what do you mean by zero-sum game? Suppose in the competitive situation or when a game is played by 2 players, if player 1 gains 4, if player 2, if we are talking that player 1 is the winner, so automatically player 2 will be the loser. Suppose the loss for player 2 is -4. That is, if we sum up the gain and loss of the 2 players, it is going to be 0. That is, if the gain of one player is equal to the loss of the other player, then such game is called zero-sum game. And if such game involves 2 players, such game is called 2-person zero-sum game. Okay. And we have another type of game which is called non-zero-sum game. So, non-zero-sum game means here also the players are, one player is going to be winner or one player is going to make gain or profits. Automatically the other player will be the loser. Okay. Suppose if player 1 in a game, if player 1 makes gain of 5 and if player 2 makes loss of -3, then the sum is going to be 2, which is not 0. Okay. That is, if the gain of one player is not equal to the loss of the other player, then such game is termed as non-zero-sum game. Okay. And also we come across with another important term in game theory which is called saddle point. So, when this saddle point comes into picture, saddle point and mixed strategies. So, we have the players will use 2 types of strategies, that is pure strategy and the other one is mixed strategy. So, the players can use 2 types of strategies, pure strategy and mixed strategy. So, when the player is said to be using pure strategy, if we can determine which strategy that the player is going to use exactly, that is, if the strategy is deterministic in nature exactly, which does not involve a probabilistic condition, then we call the player is using pure strategy. So, or else if whenever we are solving a game, if we find this saddle point, that is, if the game consists or if saddle point exists for a game, then we can understand that the players are using pure strategy. Okay. And if the game does not involves or if there is no saddle point for a game, we can say that the players are using mixed strategies. That is, exactly we cannot say which strategy that the player is going to use, and the players may use combination of the strategies. So, that is which involves probability conditions. Therefore, in such a case, that is in a game if saddle point does not exist, we can say that the players are using mixed strategies, that is combination of the strategies, right. And another important term we come across in game theory is payoff matrix. So, what is this payoff matrix? Payoff means the value of the outcome. When the player uses a particular strategy against to his competitor, he is going to make profit or loss. Okay. The quantity or the player is going to make out of his strategy is called payoff. So what is this payoff matrix? So there will be, say for example, player A might be using 1, 2, 3. Player B also might be using 1, 2, 3 strategy. Suppose if player A uses first strategy against to first strategy of player B, he make, say for example, if I write here as 4, I will explain with some examples. See, if we look at this particular matrix, okay, here 3, what is this 3? If player A uses strategy A1 against to the strategy B1 of the player B, A is going to make 3 units of profit. 3 will be the gain for A if player A uses A1 against to B1. Likewise, if we consider this one, 1 is the gain for player A if player A uses A2 strategy against to B2 strategy of the player B. So, if the values of all the outcomes of the different combinations of strategies used by the players, all such gains or losses, if represented in the form of rows and columns, then such kind of matrix is called payoff matrix. Okay, that is another important terminology which we have to understand. And the last but one is value of the game. So ultimately, whenever we are solving a game, it means that we have to find the value of the game. What do you mean by value of the game? Value of the game is nothing but the maximum gain or the minimum loss that the player is going to get or make out of the competitive situation. So, that maximum gain or minimum loss is nothing but value of the game, which is denoted with V. And finally, optimal strategy. So, we solve games normally for 2 reasons. Number 1, to find out the value of the game, and also to determine the optimal strategies for the players. Okay. So, optimal strategy is that strategy or that plan of action which maximizes profit or which minimizes loss for the players. Okay. So, such kind of strategy is called optimal strategy. So, that is the ultimate aim of solving a game. And let us consider this problem. So, whenever you are solving a game, first we have to check out whether there is saddle point in the given problem. So, how to find out this saddle point? Using maxi-min principle and mini-max for columns, we have to find, if this maxi-min and mini-max are going to be equal, then we say that there is saddle point. So, let me explain how to find out saddle point using this 2 by 2 game. There are 2 players and there are 2 A strategy, B strategy are being used, okay. Therefore, it is 2-person game, right. So, to find out the saddle point, first find out minimum value in the first row. Minimum, we have to use maxi-min principle. Remember, maxi-min principle for rows, mini-max principle for columns. So, in the first row, minimum value is 3. In the second row, minimum value is 1. And after identifying minimum value for all the rows, then we have to obtain maxi-min value. So, what is the maxi-min among these, between these 2 minimum values? Which one is maximum? 3 is maximum. So, maxi-min value is 3. And likewise, for columns, we have to use mini-max principle. That is, we have to obtain first column maximum. So, no need to by heart these things. I will give you simple clue. Rows. So, when we talk about rows are the gains for the player A. Gains means always a player wants to maximize his gains. Columns talks about losses to the player B. So, losses obviously always we want to minimize. Therefore, for columns we have to use mini-max principle. For rows we have to use maxi-min principle. Right? Am I clear? In rows we have gains for player A. So, gains we want to maximize, therefore, for rows we use maximin principle. In columns we have losses for the player B. So, always losses we want to minimize, therefore, minimax principle must be used for columns. So, first we have to obtain maximum value for each column. For the first column maximum value is 3 and for the second column maximum value is 5. In between these two, what is the minimax among these maximum values, which is minimum? 3 is minimum. Likewise, we have already obtained maximin value for rows, which is also 3. This 3 and this 3, that is this one. So, this is going to be saddle point. We have understood how to find out the saddle point. So, now saddle point itself will be the value of game, and now we have to find out the optimal strategies next. So, 3 corresponds to A1, therefore, the optimal strategy for player A is A1 and the optimal strategy for player B is B1. See, exactly we have determined which plan of action, which strategy is optimal strategy for player A and player B. Therefore, we can say that here the players are using pure strategies, or in other words, whenever if we have a saddle point for a game, it means that the players are using pure strategies. So, value of game is 3 and the optimal strategy for player A is A1 and for player B is B1. Okay, so this is how we can find out whether there is saddle point or not. Likewise, for example, you may have doubt, madam, when there is no saddle point, how to solve the game without saddle point? First, let us check out. So, whenever we are solving a game, first we have to check out for saddle point. Okay, so how do we check saddle point? Using this principle maximin minimax. So, maximin for rows, minimax for columns. What is the minimum value in the first row? 1, minimum value in the second row. So, maximin is going to be in among these minimum values, between these two minimum values, maximum is 1, 1 is maximin, and minimax. For columns we have to obtain maximum value. In the first column maximum is 3, in the second column maximum is 2. In between these two minimum is 2. Therefore, minimax is 2. That is, maximin is not equal to minimax. Maximin we have obtained as 1, minimax we have obtained as 2. So, here maximin is not equal to minimax, therefore, there is no saddle point. Therefore, how to solve game without saddle point? So, when there is no saddle point, it means that the players are using mixed strategies. Mixed strategies, that is what we can understand, right? Let us see how to solve such a game which involves pure mixed strategies or a game without saddle point. Find out the difference for the second row, that is 2 minus 0 is 2. Next, for the first row 3 minus 1, that is 2. Okay. Next, likewise for the second column difference, right here 2 minus 1, that is 1, 3 minus 0, that is 3. Okay. Now, the strategy for player A is 2 by this one 2, sum of 2 plus 2, that is 2 by 4. It is also 2 by 4, that is 1 by 2, 1 by 2. And here it is 1 by 1 plus 3, here it is 3 by 1 plus 3, that is 1 by 4, 3 by 4. So, therefore, the optimal strategies for player A is 1 by 2, 1 by 2, and the optimal strategies for B. Here, see here exactly we are not writing that player A is using first strategy, player B is using second strategy likewise. because there is no saddle point, the players uses mixed strategies, right? That is why we have obtained optimal strategy in this model. And for B, the optimal strategy is 1 by 4 and 3 by, okay. Now, the next another important thing, we have to find value of the game. How to find this value of the game? So, first 3 you can calculate using first column, second column, or first row or second row, anyhow you can do it. So, first 3 into the optimal strategy for this is, it is 1 by 2. So, 3 into 1 by 2 plus 0 into 1 by 2, 0 into 1 by 2, that is 3 by 2, that is 1.5 is going to be value of the game. 1.5 is value of the game. So, and we can understand, if value of the game is 0, we can say that the game is 0 sum game, it is a fair game. But here value of the game is not equal to 0. Therefore, the game is not fair game. So, this is how we can understand what kind of game that the players are using. Okay. And so, till now we have discussed how to solve 2 by 2 games. Let us move on to m by n game, that is where there exists m rows, n columns. Okay. So, let us consider this problem. Here we have 4 rows, 4 columns. Games can be rectangular or square, any game we can take up. Okay. Therefore, first, so whenever whatever the kind of game you are using, first try to find out the saddle point. How you can find out? First find out minimum for each row. For the first row minimum is 12, for the second row minimum is 8, for fourth row minimum is 2. Likewise, you have to write minimum for all the rows. And now maxi-min for the first row maximum value is 12, and likewise for each column find out the maximum value. For first column maximum is 40, second column it is 15, likewise. So, mini max value is 12, that is this one is going to be the saddle point. Maximin and mini max are equal, that is 12. Therefore, there is saddle point and the saddle point is 12, which is nothing but value of the game, and this 12 corresponds to A1 of player A, B3 of player B. Therefore, we can say that the optimal strategy for player A is A1, the optimal strategy for player B is B3, and the game is said to be, the players are said to be using pure strategies. Since there is saddle point, and we can determine exactly which strategy they are going to use. Therefore, this is how we can solve the m by n game. So, in this present lecture, we have understood how to solve assignment problem which is in maximization case, and also we have made an attempt in understanding basic concepts of game theory, and also how to solve 2 by 2 games which involve saddle point and without saddle point, and also how to solve m by n game we have understood in this present lecture. Thank you.